Okay, so I'm going to go to vector up top here and grab the XYZ kind of construct point component, which is over here. Let me switch over to the written names so that you can see this. Okay, and by default it's drawn at the origin of the Rhino model. We can leave this, or you can move it around depending on where the building ends up being a little bit later. But we'll deal with those inputs later. But for now, this will be our origin point. Okay, and then the next thing I'm going to do then is let's have a look really quickly at this again. I'm going to set. Right now, I've drawn a point around here. I'm going to set a point that's going to be the end point of this arc, the top point of that arc, and the end point of this arc that shares the same top point. So I'm going to draw these points, and then I'm going to start drawing my arcs through those points to start at least developing the overall form. There's probably a more elaborate process in actuality for this building that controls this overall form, but we're going to kind of start from here, again, for the sake of just kind of talking through what a method statement might look like in your own work. Okay, so I'm just going to use a couple of move components to do this. Okay, so over in transform, in the affine, you'll see the, Euclidean, you'll find the move component. You can also double click in here, which is what I commonly do, and just type in move, and you'll find the move component there. You have to give this obviously a geometry to move, so we'll move the point. And we also need to give it a vector to move along, right? What direction? So the first one, like I said, I want to kind of move it around here. So I'm going to, that's the X direction. So I'm going to double click in the middle, type in X. That'll bring up my unit X vector direction. I can plug that into the T input of move for my first move component there. And similar to what we did last week, we're going to just use the panels over in parameters panel and just start inputting move distances that we can always change and update later as we see fit. But for now, I'm going to move this one to 12 units in the X direction. I'm going to move now the same point up in space, or a little bit further, to define the endpoint of the other arc, so somewhere over here. Okay, so this is the general, this is basically setting up the overall length of the building, right, which would be this value minus this one. You could copy and paste both of these components, the X vector and the panel. That's a little faster, and you can plug that in there. And then change this 12 to 55 for this example. And you can see that just, based on the units that I have set here in my file. I'm going to go a little bit off the grid when I do that. I usually like to make sure all of my work stays on the grid. This is up to you. You don't necessarily have to do this part, but I'm going to copy and paste the panel here, and I'm going to move this thing back. I don't know, I'm going to say minus 15 to see if that brings us back. I'm going to move it back in the X direction a little bit, like so. There we go. So now it's kind of all at least sitting within the grid, close to origin, which I think is nicer. Okay, and then the last point I want to do, I'm going to set the height of the building, okay, and that's the kind of top point of both of those arcs. So I'm going to copy and paste this stuff out again, maybe just the move. Oops. Take the move, because we need another move. And this time, though, we want to move something up in the Z direction, right, up in this direction. So you can double click in the middle, type in Z. Your unit Z will pop up, and you can plug that in there. I'm going to grab one of these panels again by copy and pasting that, and I'm going to set this to a value of 50, just to see where that takes us in terms of our form. So we have our top point, bottom points, and this is a kind of a reference point that we've kind of moved beyond already. Okay. Okay, so now what we'll do is we'll just draw some arcs through this using a component that's pretty handy when it comes to drawing arcs, because we don't need to draw them as subset of circles in this case. We can just draw them as arcs in order to get us started. So I'm going to go to the curve tab, and head over to my primitives box, and inside you'll see down kind of toward the bottom on the left here this arc SED, start end direction. Okay, so we're going to grab that one. And we're going to have to input now the appropriate points. And I want my start point for each of these arcs to be this point up top here, because this is the point that's going to determine where the direction starts in order for me to determine the curvature. And you'll see that in just a second. I'm not going to explain that until you get a visual on it. So anyway, this is going to be our start point for this arc, and each of these are going to be an end point for two different arcs, right? So we'll start with the top one, suppose. And now it's going to stay orange for a moment until I input my my direction. And this is going to be a vector that I can rotate in space in order to change the curvature of this arc. By default, just to get you started, let's pop in a z direction vector. Okay, and you'll see what the effect of this is. So let's just double click that. And okay, so now I've got a this is basically drawing a vector from this point upward like this, and that's going to set off a tangent, right? And that's going to draw the arc between those 2 points, using that direction as a kind of a reference. If we reverse this, we'll draw the other subset of this arc. So we'll draw this one here, subset of the circle. So all we got to do is you can go into Vector tab, grab this in the vector box, grab the reverse component, and reverse that. And now you'll see that we've drawn the arc between our two boundary points. Now we can change this a little bit. This is the smoothest curve between those 2 points, given the kind of arc geometry that we've set. But we can change this a bit by rotating the vector that's coming off here. And the one thing I want to do is just visualize that vector for you so you can see it. So I'm going to go into the Display tab here. I'm going to choose this Vector Display component with the orange arrows. And then before I keep going, I'm going to go back to Vector. And in the vector box, there's something called the amplitude. This is going to set basically the kind of, let's say, the strength or the magnitude of a vector. And it's going to allow me to lengthen it. In this case, it won't matter in terms of the form, but it will at least show better. The resulting arc is not what we want to visualize. We want to visualize the vector itself. And the anchor of that vector is going to come from our start point, right? Because that's where we drew it from. That's how this component works. Now the vector we're visualizing is the one that we've just reversed. So I'm going to put that into my amplitude and plug the amplitude into V. Now the amplitude has a nice little input here, which is called a length value, and that allows me to change the length of that vector as I'd like. So I'm going to put a panel in here and just plug in something like 15. I'm not sure how long it needs to be just yet. Okay, that's not bad. I think we get a good kind of visualization of it on screen. You can kind of see it now being drawn for us as a representation of where that vector is going. Okay, now we know where we're going, at least what direction we're facing in. The last thing we need to do now is get a little bit more control over that vector. And I'm just going to move this stuff out of the way because it's just a visualization. A lot of times I like to just move that away. The other thing I'm going to show you right now is how to kind of change the visualization of these lines. Sometimes it gets a little heavy on screen. And with these kinds of things that I don't really need to kind of pay much attention to after I've used them, I usually like to right-click on the input letter, right, in this case V, and the wire display, you can change that to faint or hidden. I'm going to change it to faint. I'm going to do the same thing for the A input. So again, that's right-clicking on the input that the wire is going into, changing our wire display to something like faint. Okay, and then that's going to kind of free up my screen a little bit so it's not so heavy. Okay. Last thing again is to rotate, so I'm going to go to Vector tab, Vector box, rotate, and I'm going to use, this is the vector that I'm rotating. It's going to ask you for a rotation axis. That's the axis that's coming toward us in the screen, right? Because we want to rotate against this view, which by the way, I'm in the front view. I should have probably mentioned that before. So if you're not seeing anything and you're kind of in the top view, it's because we've drawn so far in the XZ axis, okay? So you're going to want to go to the front view. And you'll see this. Now, because we're in the front view, the y-axis is the axis of rotation, so we'll double-click, type in y, grab the y-axis, pop that into the axis there. Last thing is to set an angle. Right-click on the A input and hit degrees. Okay. And now we can just set a slider in there. So I'm going to double-click in the gray area again and just type in 20, well, maybe something lower like 10. And you can grab a number slider now that's drawn out between 0 and 10. I'm going to right-click on that slider and make sure that the slider type is floating point. Just get a little bit more of a gradual rotation out of that, which I think is better. And then I'm going to replace this original, the one that we had here, this reversed vector. I'm going to replace that with our new one that's been rotated. And now I need to update my visual. Okay, so I need to kind of go back and do this too, so that I've updated what vector we're actually visualizing, so I can actually see it. And now if I change that the slider value, basically rotating the vector in space, you can see that I'm changing the curvature of that arc. Okay, so I'm going to leave it at 10, and we can always go back and change it later, but this is starting to set up for us a kind of a solution space of this building form, right? We now have, this is a section of the center of the building, through the center of the building. You can see that I'm starting to manipulate that a little bit, and giving myself kind of a range within which possible solutions can occur. Okay, and that's important using these kinds of tools. Okay, I'm going to do that one more time, that whole kind of series of steps, and I'm going to draw an arc now through this point and that point. So if you'd like, you could copy and paste all of this and just plug in the right inputs, and we'll do that. We may have to do a little bit of changing of our vector direction, but we'll do that in a second. So I copy and pasted all of that stuff. Our start point stays the same, but our end point gets replaced with the other point. And yeah, because we've reversed that vector, we know now we're drawing the wrong arc. So we can remove this, delete that, that reverse, and just use the Z for a moment. And you can see also that we're still drawing this incorrectly. We're putting this up again in the top, toward the top of the screen. We want to be drawing a vector actually in the X direction in this case. All right, to kind of set that tangent that's a little bit more, kind of carefully set that tangent to something that makes more sense. So double click, type in X in the search, and grab that X in there. Delete that Z. Okay, so we're getting a little bit closer, but again, we want some more control over this, so we want to be able to rotate this vector a bit. Now, what I'm doing here is I'm putting it back down to 0, and I'm getting a better result. And the reason is that if we visualize this vector as well, okay, and if I kind of just hold down Shift, like we did a little bit last semester, maybe I talked about that last week. Hold down Shift and input also that vector into our display. Scratch that. It's a little bit easier actually in this case because we have to give it a different anchor point as well. Okay, sorry. Somebody walked in my office, had to pause. But where was I? I was putting in a vector. I put it in, just a second ago, I put it in the wrong input here. It's actually fine because they share the same anchor point. So I can just take this, hold Shift, and put it actually into the V input of amplitude. And you'll see that now being drawn. Now, the thing is, though, as I was saying before, what we need to now do, instead of rotating this thing downward, as you can see what's happening here, we want to rotate it upward to give this thing a little bit more shape. To give it a little bit more curvature, kind of like that, to define our building. So that's a simple thing. All we need to really do is just reverse the we just need to reverse the angle that we're inputting here. So we can make this value a negative. There's a couple different ways to do this. This quick one is to just kind of right click on A input of our rotate, go down to the expression editor here, and just type in -X or -X, and then commit changes. So that's going to convert all of those values into the negative version of it. So here I got 8.7. I hover over this, it says -8.72. That's being input. Okay. And now I'll crank that up to 10, and I get what I think is a closer representation of the section through this building. Again, we can always go back and change these things a little bit later once we've developed the project a bit more to really kind of fine-tune that form a bit, and we can even increase this slider if we need to. But that's the basics. This is forming our first set of input parameters, if you will, that are going to determine the building shape. Okay, so we've got the length of the building, the height of the building, the amount of distance that this arc needs to travel in order to kind of get this this kind of lean back, and the rotation vectors that control the curvature of the arcs. Okay, so that's a pretty big step forward in terms of getting this thing started. Okay, now the next thing, let's have a look again at our method statement. It's going to be this. So we're going to start cutting in our floors. And there's many different ways to do this. I'm going to show you one that I think is useful. The thing that we're going to do also is determine, we're going to first set a parameter that pulls up the first level here. You can see that. So we're going to set that as an input like we did before, just with a move. And the other thing we're going to do now, we're going to determine the overall number of floors and where that top floor ends based on a point along this top curve here. Instead of just kind of saying we got a 10-foot floor or something and we just have 8 of them, we're actually going to see if we can determine this using a parameter that's drawn along the curve itself, which means that if we change the shape of that curve, the floors will update. Right? And we can look at that a little bit later. And that could be an advantage depending on what you want to do. Anyway, that's the way I'm going to do it here. Okay. First things first, let's figure out how first we're going to kind of cut into these two arcs. And I'm going to use a simple projection to do that. But in order to project something, I need to actually draw the points somewhere over here that I can project back in that direction. And I'm going to use what I have on screen already instead of inventing something new. So I'm going to use this point, move it over a bit, pop it up to whatever value that I think is, or whatever height I think is appropriate to start the first floor there, and then we'll go from there. Okay, so this is pretty straightforward. I'm just going to, this is the point that I want to move, and I want to move it again. All right, I'm going to move some stuff out of the way here in order to kind of, and I'm going to go to the parameter step up top, grab this little point component. And the reason why I'm doing this, I'm kind of copying the point down a little bit, and I'm just using this method to keep my file a little bit more organized. Sometimes, if you have an output that's very popular later on down the line, you've got a lot of outputs coming out of it, and it just kind of makes a mess of your screen a little bit. So I'm going to move this down here, and I'm going to start working now down in this space in order to keep things slightly more organized. So again, we want to move, so I'm going to double click, type in move. And I'm going to move it just a little bit in the X direction because I don't want this thing to get too close. If I change the curve and then this thing doesn't update, I might have some problems with the projection if it's not on the outside of it. So I'm just going to avoid that altogether. Double click X, throw in an X vector, and I'm just going to move it. I'm going to grab a panel. I'm going to move it of, I guess, 8 units, which is fine. It's an arbitrary number. It's just something to kind of keep us at a little bit of distance here. You can use a different number if you like, but I'm also going to use that number later in order to set the height as well, kind of square that off, and you'll see that in a second. Okay, now I'm going to move this point one more time up, and that's going to set, again, my bottom floor. So, okay, so double click, move, all right. And this is the point that I want to move, not the old one, but the new one. So I can turn off that preview. I guess we don't really need to see it. Now this time I want to move in the Z direction, which by default is already happening, but we need to customize it. So I'm going to pop in a Z there, and I'm going to use the same panel that we used here to set that height. So I basically moved it diagonally, right, up in space a little bit. Okay, so that's the start at developing those floors. Okay, and the next thing is to give, to kind of determine, we've determined our bottom, the lowermost point that we're going to set our floors to. Now we're going to determine the top, and like I said before, we're going to use a point along that arc to do so. So I'm going to go to curve, and I'm going to evaluate that curve using the evaluate curve component right here. I'm going to grab the right arc, which is this one, and use that as my input curve. And this is a T parameter. You might recognize that from earlier examples that we looked at. But over in parameters, I'm just going to grab this here slider between 0 and 1 by default and start drawing my point. Now, you can see that when I move this, I'm going to zoom in a little bit here. When I move this thing from 0 to 1, you might be thinking, well, what's going on? It's not drawing it across the entire arc, so you might be wanting to change this parameter to something higher, right? Maybe between 0 and 100. That's not the right move because you have no way of knowing how far that point needs to go using some random numerical data point in order to actually hit this. You don't know the boundaries, right? You don't know the numeric boundaries. And there's a simple way to fix this in order to parameterize this between 0 and 1, and that's right-clicking on the C input and just clicking reparameterize, okay? And that's what that's going to do. That's going to make sure that our arc now is being described on screen between 0 and 1. So I can, any kind of T parameter that exists along it within the boundaries of 0 and 1 will be drawn as such. So 0 is at the start point, 1 is at the end point, 0.5 is in the middle. We're going to use this as a way to kind of set our parameter anywhere we want. Now, of course, if you're designing this building, you got to think about this as a sketch because again, you're probably going to want to know exactly where this is, relative to some other factors in the project. But for now, again, because it's a sketch of form, we're going to just kind of determine this arbitrarily. I'm going to use I'm just going to leave it here at about 0.31 or something. You can kind of put it in a similar area. I've tested this, and I think this looks kind of proportionally accurate, at least. Okay, so we've set that. So we've got our point here, and we've got this point as our top point. The question is now is how do we kind of compare them in order to find our overall number of slices. Well, let's do that. We're going to deconstruct this point to find its z-value. We need to know where this thing is in space, right? So what's its z-value? What's its height? We know the z-value of this one because we set it manually over here. We're going to subtract the high z-value from this one to find out how far apart these two points are in the z-axis. Okay, so we're going to go to vector. This time we're going to deconstruct the point, as you can see there, and get that information. So there's my z right here. And then I'm going to go over to Maths tab and grab my subtraction component. And I'm going to plug in the z output there into the top value. And then I'm going to use this panel that we used down here, this panel of 8, and put that into B, because I'm going to subtract that value from, and I'm going to, just try to stay organized here. That looks a little bit more clean. I can read it later much more easily. And now I got a result 39 point blah, blah, blah. Okay, that's fine. That's how far apart we are in terms of our units here, which are abstract now because we haven't really set. This is not being drawn one-to-one. Again, it's a formal sketch. But that's our boundary. That's our z-axis kind of bounds. Now we're going to use that as a way to draw a line, right? We're going to need to draw a line up from here to an end exactly at that point. Instead of kind of drawing a construction line over and finding the intersection, which would take a little bit longer, I'm just going to go to curve and line SDL. This point over here is my start point, right? Because I want to draw that from there, right? So this is the point that we moved over here. And I'm going to move this in the z direction, so I'm going to double click, type in z, put that into D, okay? And now we just need to give it a length, and yes, we're going to use the length that we just found from our subtraction to draw that line, okay? And you can see now that I've drawn that line to the exact z coordinate of that point in space over here. So if I go through and I change the location of that point, you can see the line updates, yes? Yeah. Okay, so dependency list. I'm going to go back to 0.31 like I just did and leave it at that. Alrighty. So let's now develop a series of points to project this way along both of these arcs so that we can start drawing our floor plates, I guess, across the two of them. All right, now we need those to be flat. We know we can't just divide these two arcs evenly because they're two different lengths, so we can't really divide them evenly in order to compare them to connect the dots. That'll be a crooked floor. So that's why we're going to use the project method. All right, so over in vector, point, and project point, that's the component we're looking for. Now let's hover over it and look what we need here. It's going to need points, it's going to need a direction, and it's going to need the geometry to project onto. Now one thing we don't have yet, we have the geometry we want to project onto, direction is easily set. We don't have the points yet. Okay, we're gonna use this line to develop those points by dividing it. All right. So in my curve tab, curve, division, and divide curve, I'm gonna start developing that point set. Now we need to set this as a parameter. This end input is going to give you the number of segments in that line. So a value of 10 is going to give you 11 points because it has the line always has an endpoint. But it's going to give you 10 segments between those points, right? So essentially that means 10 floors if we were to project this. That might be a little bit too many for this, so I'm going to plug in a panel again, and I'm just going to plug in 8 into my n value and use that as my. So this is in a way a secondary parameter. Okay, we've gone through and we've drawn out our overall form, and this is the number of floors that we're going to put through that form, and in a way it's a kind of a secondary parameter, if you will, just like this one is, right? So we can always change this one a little bit later as well, if we want to kind of determine our floor heights relative to this point up top. We could always drop this a bit, increasing the floor heights. We could do a lot of different kinds of things with that. But anyway, that's now been set. We can go back and change that. But because I'm not going to change that often, and that's a value that's probably pretty strict, I'm going to use a panel instead of a slider. And that's usually how I decide between the two. Okay, so we have our panel, our points. We can go ahead and just plug those into P here, because that's almost ready. And we need to give this a direction. By default, it's, for whatever reason, negative z in the negative z direction. I guess that's more common to project downward onto the kind of xy plane. We're going to project backwards in the xz plane, so we want a negative x direction. Okay, so type in the middle. We can search, double click in the middle, search for your unit x once again. You can plug that in there, but we have to, again, reverse this. Okay, so double click in the middle. We can just quickly find that reverse component there, and now we're going to kind of put that along, push those points along in the negative x direction, which is what we want. And the last thing now is to just input the geometry that we're projecting onto. And we have two arcs here, right? We need to keep those arcs separated as separate data in order to get separate sets of points that we can then compare and connect the dots. So we have to be a little bit careful with what we input into here. So here's what I'm going to do. These are the two arcs, right? We have this one and that one. So I'm just going to put a little window around those. And I'm going to grab one of these curve parameters here in the parameters tab. And I'm just going to set them both in, being mindful, I guess, a little bit over which one goes first. So the back one will go first. And then I'm going to hold Shift, okay, and I'm going to input the second one into the same component. And now if I click this, both of them are being selected. That means they're both being put into this box. That's good. And now I can kind of bring this, I guess, a little bit out. So I'm going to plug it in over here. But before I do that, you can see, we have two arc-like curves. They are in a single list, which means when I plug this in, we're not going to get the results we want. It's only going to pick one of them. It's not given enough information, really, to figure out which one you want to project all these points onto, because we haven't separated the two of them. That's simple. All we need to do is just right-click on that component there and just graph these into their own kind of separate lists, right? Now you can look at that data structure as being very different. It's no longer a single list. It's a list of two lists of one item, right? So it's two separate lists of one item instead of one list of two items. So because of this data comes in. The first line here gets compared to the points, and so does the second one, but independently. So the computer is doing that very quickly, but it is kind of going one at a time. And now we've got our sets of points being projected across in that direction, perfectly flat, because we used a vector for that. And you can see now my data is good. I have 9 points and 9 points, 9 for each arc. Okay, so what we're going to do now is draw the lines across, and we're going to use those lines to find a center point from which to draw a circle that will define our floor plate shape and size. And we're going to use the diameter that's set by the distance between those 2 points. Okay, so let's do that. Now, because our data is broken down into two different lists, we have to do a little bit of work here to access that stuff. Okay, sorry, I had to pause again. So just to repeat what I said before, we have to break this data down into its separate chunks so we can actually compare the points in order to draw the lines across them. Because if we go over to curve, grab our line component, you can see that we have two inputs, right? One set of points and the other set of points. That's going to be hard to do from a single output. Okay, so we go over to sets, and I'll introduce you to a couple of the tree components. In this case, just the explode tree. Okay, so sets, tree, explode. In this case, quite good because we have a limited number of things that we're actually outputting here. In this case, very simple. We can just leave it by default to have two outputs because that's what we have coming in. And now what we've done is essentially just separated that data inside of each of those branches. Okay, and we can just simply go ahead and plug in across from A to B like that. And you can see in the same logic, right, that is actually kind of visually shown in this component is how this works, right? So we're just crossing over, right? We're just kind of connecting dot to dot. The reason why this works is that these are in order, right? We projected this is already in a certain order, 0, 1, 2, 3, 4, and so on. As we project over, right, it's going to maintain that order. So that's 0, 1, 2, 3, 4, blah, 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 and the same over here, right? So it's maintaining the order. It's keeping things organized for us. It's making our lives a lot easier. Okay, so this is the beginning of kind of breaking down this this section into a series of bands that we'll kind of use to form the enclosure of the building form. All right. Okay, so in order to do that, now the next step is to get into 3D. Now we've been working in the front view. I'm going to double click out of that and go into my perspective view and have a look at it in this view, because the next step will kind of show this now in 3D, which is to draw our circular floor plates. Okay, so we're going to draw circles. All circles, of course, need a center point, so we're going to go to curve, and we're going to use this little point on curve component here. And by default it's set to 0.5. That's good because that's its exact center, so we'll just use that, and you can see all the center points being drawn. And what we need also is a radius for each of those circles, and in order to find the radius, I'll need to measure how long these lines are, which are actually the diameters, and just divide that by 2. So in my curve tab I can find here the length component, right, the curve length component. And I'm going to grab that, plug that in. That's going to give me a numeric output that I need to divide into 2. So I can either go to maths, divide that using this, or I can just right click on the L output, go into my expression editor, and just type in x divided by 2, x/2. Okay, so now everything coming out of there is now half of what it was. And that's our radius for our circle. So I can go to curve, grab my circle component here, use that as my P input, and plug in my radius input there, and now I've drawn all of my circles. Okay, so we're starting to now kind of develop a skeleton, if you will, of the City Hall. It's starting to resemble a bit more of the building, starting to kind of flesh out the form a little bit. We're starting to get a sense now for what the massing is starting to look like a little bit. But the thing wasn't modeled as a mass. It was modeled as lines. It was modeled as as line work that was then kind of turned into and converted into surfaces, and that's kind of why we're going through the process that we are in order to kind of exact those changes using this kind of geometric parameter set. Okay, so this is a good step. From here now, it's going to be important to kind of follow along and pay a little bit of attention to the kinds of little things that I'll be doing, because it's going to be easy to find some errors here if a couple of small steps are missed. What we want to do next is we need another arc back here to control the shingling, if you will, or the kind of the step back of each of these bands, the surface banding. Let's go back to my image here. You can see it in the back here, right, if you follow my cursor. All right, so over in the front, it assumes a pretty, they kind of tilt forward, right, to kind of to make that a smooth curve out front, and that's to kind of accept sun and so on. Over here, though, it's different in that there's this kind of stepping that's occurring, and so there's a different section that has to be drawn there. You can't just kind of connect the dots across like we can over here in order to find that form, which means this form is now by its very nature, getting subdivided and broken down into these bands, which are representing each of the floors of the building, as opposed to kind of breaking down a form later. So the form is actually built up in a broken down kind of fashion, and that's how we're going to model it. But we need to figure out how we're going to determine what that top point is. You know, because basically we have a circle here that we've drawn at the bottom, but there's a top circle to each one of these, which actually we won't draw, but we will at least need to find a point that we're going to use to kind of draw a section, right, at that center line across the building there, to draw a line up to determine how we're going to kind of sweep that circle. Okay, and if we look back also really quickly at this thing, we can see that there's an arc here. Okay, you can see it right there. There is an arc, another control arc that determines all of this for us, and I think, yeah, I guess if I zoom in here, you'll kind of see how the dots are being connected from one arc to the other, where the intersections are occurring. All right, so that's what we're going to do. So let's follow along a little bit here, and I'll try to be as clear about this as I can. Okay, the first thing is to let's just grab the points we want, and it's just these back points. Okay, so I can turn off this preview for now, and go to my parameters tab, grab a point parameter, and just kind of, in my case it was the 0 output. The 0 output is going to be my back points, and I'm just going to kind of label them so I don't forget. So it's the back points, all right. Okay, and there they are. Now, what I want to do is start organizing this data in order to, first of all, draw the arc as I want. And then after that, we're going to use that reorganized data sets to start making connections between the two arcs. But first things first, let's draw the arc. The arc is going to be described between, similar to the ones we did here, right? This bigger arc is being described between top and bottom point. We're going to do the same thing, same tool, and we're going to use this point as the bottom and that one as the top. All right, so let's isolate those points. We know we have a single list here. So this gets into some good stuff that a lot of you have questions about, which is how do I select something? And that's what we're going to do now. First things first, let's select the bottommost point. All right, I'm going to go to Sets. I'm going to grab my list item, and that by default is going to basically do that, right? Because we have a 0 index as a default input. That is going to give me the first point in the list, which is this bottommost point. Okay, I can label that so I don't forget. I've identified and I've found my bottom point. Now we need to find the top point. There's a couple different ways to do this. We can measure how long this list is, use the same component but put in that number into item index. I like to do something like this, which is to just copy and paste that same component, right click on the L input and click reverse. It's faster, and what that allows me to do then is just reverse the order of that temporarily using the same index as 0 and finding the topmost point because I've reversed the order. So what used to be the first one is now the last one, and so on. So I'm going to label that top. And then I have to remember at some point it might be important for me to reverse this again later, and that'll be important in the next step, not in this one. Okay, so we have enough information now to get started on making that arc, right? But I want to also, I need to remember that these points need to move a little bit, kind of similar again. You see how these are kind of moved away? This one has a slight offset, this one has a larger offset. I want that to be something that I can control. Simple, we're just going to use those move components again, like we did before. Okay, so I'm going to double click, type in move, and I'm going to pop in a move component into both of these. By default it's going to be in the Z, that's okay for now, we're going to change it. Double click, type in X, it's going to be our unit X, and I'm going to plug in a unit X into each of these T inputs for those the move components. And then I'm going to grab a slider. I'm going to type in, just double click, type in, I guess 5, grab a slider that's between 0 and 10, right click on it, change its type to floating, like I did there. And I'm going to plug that into this one. So this is the bottom one, okay? And I can see that on my screen I'm moving that back and forth a bit. I'm going to move it to, I guess, a unit factor of 3. And then the top one, I'm going to put a different slider in that. And I'm not moving this one much, right? This one is actually being moved very little, so I'm just going to use a default slider for this, between 0 and 1. And just move it a touch. Okay, I'm going to move that, I guess, 0.5 units over, which, again, is an abstraction, because we're not really dealing with full-scale modeling here. But again, so I moved that just a bit, because that's going to give me a result that I think is good enough. Okay, so here's another set of inputs, kind of tertiary parameter sets that we would need to kind of determine that back angle, that step back. So let's draw our arc. You might already be moving ahead if you're getting the hang of this. We need our curve, arc SED, start point up at the top, end point at the bottom. Then we need to give this a direction. And so just follow along here. I'm just going to crank through this. The first thing we need to do is to kind of rotate the vector. We know that because we want some control over it. I'll type in rotate, find the rotate vector component, pop that in there. Let's give it some inputs, but first I'm going to make that degrees, so I'm ready to input a couple things in here. The vector I'm going to want to rotate is a Z vector. All right. So this is the vector, yeah, and I want to reverse that vector like we did before, kind of pointing downward. And the axis, again, is going to be the y. So I'm going to grab a y. And then, of course, the last thing we need is just a numeric input into the angle. And for that, I'll do something similar again, kind of type in a slider with the value, top value of 10, and pop that in. All right, so if I just pop into my front view for a second, we can have a look at what we've got. And I can see that I've got a little bit of control over this, right? I can move the top points back and forth, the bottom point back and forth, and I can change its angle, or its curvature. I'm going to leave this at something like, I don't know, let's just make it 5.5, which I think is a pretty good offset. Kind of starts tangential and it kind of peels away nice and naturally. I think that's visually at least, that's a good start. Okay, I'll go back to my perspective view and just kind of get used to looking at it in that view. Now I have my arc drawn. What we want to do now is find the intersection points, because we want to be able to connect that point to this point, that point to that point, like this, right? To start building the back of each one of those ribbons. All right. So we need to find the intersection. So we can go to the Intersect tab. The first component there is curve and curve, so it's going to find the intersections between two sets of curves. The first set of curves is our arch, right? That's the one we actually drew, the arc. And the next set is the lines that we drew across, right? That's what we're going to be intersecting. This line to that line. That's drawn here. Okay, so I'm going to pop those in over there. Kind of move this a little bit so I can see where that's going, future reference. And there's my intersections, right? So again, if I go back into my front view, you'll see all the intersections being drawn. Okay, so we got our points. Now, let's look. All right, we have 9 points here, and we have 9 outer points here. If we want to start connecting these points, think about what you need to do. You've got a set of points. This is the 0 index of the first set. This is the first index, the 1 index of the second set. So you want to go 0 to 1, then you want to go 1 to 2, then you want to go 3 to 4, and so on. So what you need to do is reorder one of these lists in order to make that work, because the line component, again, takes an input of A and an input of B. And it's going to compare across. Now, the other thing we need to do, if you keep going down the line here, so we need to remove this point, yes? But if we keep going, we're going to end up connecting this point to that point, which means we have an extra over here. We have to remove that one as well, because if we don't remove this one, it's going to get confused. So we have to compare 8 points to 8 points as opposed to 9 to 9. Okay, so let's walk through that a little bit. First thing is let's remove the top one first, okay? And sometimes I like to kind of see ahead of myself, so I'm going to go to my curve tab, grab my line component, and let that thing get ready. I have my original set of back points over here, and I want to remove the top one. I actually just want to get rid of it. So these two aren't going to work, because this is only giving me 1 point at a time. I want 8. So instead, I'm just going to go to my sets, call index, right, the first one in sequence. I'm going to plug that in. Let's put in a value of 0, so I'm going to grab a tab or a panel for this, plug in a value of 0 into my index, like that. Now what I've done here is I've removed the bottom one, but if I reverse it, I've removed the top. Okay, you can see now it's no longer being selected. Okay, now in order for me to now this again is kind of a hack. It's a little bit of a trick, if you will, because I've reversed the order, which is not technically not a good thing, because I need that order. But I've done it only to kind of isolate and get rid of that top point. So if you're going to use this reverse trick, then you have to reverse that data back to how it was before in terms of its order, but removing that top point from it. So this is a double reverse action. So I reverse here, I reverse as my output so that nothing gets confused later, and I'll pop that into my A input in my line component. Okay. Now the last thing is to go ahead and remove the bottom one of this set, and for that I can use the same component, sets, call index, input the L. In order to get this to work though, I need to flatten this. Okay. I won't really discuss that in too much detail, but we need to flatten that, and The culling index is going to be 0 because that's the bottommost point that was drawn. Now I've removed it. Can turn off that preview. And now I can use these to input here. And you can see what it worked perfectly, right? So 0 to 0, 1 to 1, and 2 to 2, and so on. And that's because I'm comparing 8 points to 8 points. It's just that they've been kind of shifted away from one another as two data sets. And now we're getting the beginnings of our basically the angle at which this ribbon, when a surface is drawn, is going to kind of meet the end of the form. And because of that, we're getting kind of a sawtooth thing that's happening, kind of like in the building. Okay, so that's an important step. We've gotten through a kind of a tricky listing process. I went through it a little bit fast, so if you have to go back and check that out again, if you have any errors, raise your hand. We'll go over that. But that's an important one. We're almost there. One of the last things we need to do now in order to make our surfaces is just to connect these points out here as straight line segments, right? Because what we're going to do next is kind of use this line we just drew and that straight segment as cross sections for our sweep command. And we're just going to sweep that circle with those two cross sections, creating our building ribbons, our surface ribbons that will eventually become glazing and the kind of, the envelope of the structure. Okay, so this time we're going to act on this set of points out here that we haven't isolated yet. So going back to this explode component, the one that says bang, we can go to parameters, grab a point, and highlight those now. From here. So it's the one output, and there's that. I'm going to put it up here like another arm coming out of this and start working in this area. Let's see if a quick way of this, I did a different way earlier. I'm going to use a faster way maybe this time, and that's just to draw a polyline through these points, and then we can just explode it. So I'm going to go to curve, spline, and grab the polyline component. Okay, and that's going to draw a series of straight segments through those points, and if I zoom in, you'll see that. You'll kind of see that happening there. The output is a single polyline, but if I explode it using my curve tab, utility box, explode, I should be able to just break those down now into separate segments, like so. And now I've got my 8 segments. So I have 8 line segments that can be compared to my 8 line segments over here. Right? And we're going to use that as a way to develop our sweeps. All right? Okay. Now, before I get any further, again, I'm dealing with 8 sets of 8, right? So, 8 sets of items, right? So I have 8 of these. I have 9 circles. That's going to be an issue if I'm doing some sweeping, right? Because I'm going to, if we look at our side view for a minute, here I've got this line going across as a circle. That's the first one. I'm going to use these two, this line here and that line there to sweep. Now, if I go all the way up to the top, this top circle here doesn't have any lines above it, right? And we don't want to sweep that one, and we don't want to even use that as part of our data because we'll have a duplicate surface being drawn up top. That's a likely error that you'd find if you were to do this on your own. And then the simple fix is just get rid of that top circle. Kind of like what we did before when we were getting rid of top points in order to compare them right. That's easy. Where's our circle? Here's our circles. We go back into set, use our call index once again. You can just pop in a 0 because it's, again, the lazy way, and I can reverse this order. And now I've removed, now if I select that, I'm selecting only the 8. I'm removing the top one from the list entirely and letting that just kind of be on its own. And again, I want to reverse this back again so that I don't get the data confused later. I don't want to compare a reversed order with an order that's already been set from the ground up. Okay, so one of the last steps here is to do some sweeping in order to make our surfaces. All right, so let's do that. Let's look at what that component needs. So let's go to Surface, Freeform, Sweep 1. We don't need to sweep 2 because we haven't drawn actually the top rail, because in this case, again, perhaps we don't need it. Rail curve. Now we know our rail curves are going to be our circles. Okay, let's do that. And just before we plug anything else in, let's follow along a little bit. Now we need our section curves, right? And we have 2 sections per circle that we want to sweep, not just 1. So we actually need to take these and these, okay, and merge them into a single data set to put them into here so that it's organized. So let's go to set, introduce you to a nice one called merge. Okay, I'm going to take the S output from here, and I'm going to take the line component from there, and I'm going to merge that all together into a single data set. Now, by default, for whatever reason, I think it's kind of silly, it automatically, this component automatically starts adding inputs for you. Just delete this third one by zooming in. It's not going to mess you up, even if it's blank, because it's not as if it gives you any kind of output, but it bugs me, so I like to get rid of it so I don't get confused. So now if I look at my output here, I've got a grafted list. I've got 2 branches, and I've got 8 items on each. That's fine. But the issue now is that this data structure doesn't match the structure coming into here. So what we need to do is graft this input in order for it to match up. So now if I look, I got 8 branches ready to accept some branch work, but I still have an issue, right? I have 2 branches here with 8 items on each one. Here I've got 8 branches with 1 item. The easier one to match is this one, because I can take this apart and reverse it. I can reverse this to being back to 8 lists with 2 items each. And that's a simple process. If you go to tree, flip matrix, or you can also double click and type in flip, you'll find the flip matrix component, and you can plug that data structure in there and see what it gives you. The output now is exactly what we want. Now we have 8 branches, each with 2 items, which means those are the 2, what that represents is the 2 section curves that we're going to compare to each of the 8 circles. All right? So 8 sets compared to 8 sets, 2 items compared to 1 item. It's fine. So we can pop that in, and you can see now that we've drawn this without any problems. Any issues, weird stuff going on at the top, or if you've got a mess that's happened here, just raise your hand and we'll come over. I'm going to turn the preview over to the blue ball over here to high quality. I just think it looks better, and have a look at what we've got. Now we've got something that's pretty close to resembling at least the general form of the building. I think we're in pretty decent shape, and it's probably time now to just go ahead and see what our parameters do for us in terms of subtle changes. The first one, I kind of go back in time a little bit just to where we were. And remember we set that arc over here, right? Now if I change the shape of that arch, you can see that I'm changing that back angle of each of those ribbons, right? So I have that control. I can play with that a bit and kind of determine what I think is appropriate. Other kind of information coming into the project later would determine this in a more real way. But for now, I got a good sketch. I can also goof with this. I can go from, this is kind of interesting because now I can go from an obtuse angle, slowly, gradually turning into an acute angle as the curvature changes. It's kind of nice. Or I can leave it kind of like how I had it. It's a little bit more like the building, maybe. Maybe this is a little bit more like the building, around there, 2.5. And again, I can kind of squeeze that in a little bit, and I should have no problem. But that's a minimal input. You know, and also going back in time, you know, all the way back to here, I should have no issues updating this. Changing the number of floors that I get, right? Number of ribbons. I should be able to change where it exists in terms of the height. Let's drop it down a little bit, make them all a little taller. Same number of floors, higher floor to ceiling, because it started a little bit lower on the arch. You see what I'm doing? I'm kind of using now the solution space in order to make these changes, and I can do that really quickly. I could change the overall form, and everything is updated nicely. Here we get an issue, and I can explain that maybe verbally. One of the things is now is that we're in order to make this truly parametric, this rotation angle actually should be linked to the smaller arch, right? This one here, the smaller arc, because if I go too far, it's going to kind of pass it. The outer arc is going to pass the inner arc, and then I'm going to have that problem. It's not hard to do. All I got to do is make this input numeric value contingent a little bit on one of these, which is probably going to be our move, this one here. And we can kind of, as we decrease the other one, this one could increase. Maybe a future example could show that. So we do have kind of conflicting parameters, and that's not good. It makes our file a little less robust. But honestly, we're working within a kind of a solution set here that probably wouldn't even put us in that position. And then, of course, I can make these changes as well. So I could, make this slightly more even, kind of increase the lean back, if you will, right? I could change the height. Should have no issues. So this is kind of bringing that in much further, making this a little bit more like a, and the overall height, could also increase and decrease. Okay, you get the idea. So our geometry method statement is strong in this case. It's working within the boundaries that we've given it, and we can make changes within that solution set as such. Now, you could basically end here. I'm going to go a little bit further, and I'm going to break these surfaces down into panels, and kind of like what we did last week. And I'm going to show you kind of a fun little way to take it all apart into these kind of unrolled strips. And I'm also going to show you a way to kind of make the number of subdivisions rely on the area or the length of the bottom curve that we use to do the sweep, so that it's again, there's a geometric parameter that affects how many panels are being drawn across. Okay, so let's play with that for those of you who are interested in continuing. This will only take another maybe 10-15 minutes or less. So I have a series of surfaces that I know I want to start affecting, all right, and breaking them down, subdividing. We did this before, so instead of using Lunchbox in this case, we're actually just going to use the default components. And I'm going to go to surface. I'm going to grab this ISO trim. See my data here. Okay, that's good. And I'm going to go to math, domain, all the way at the bottom, divide domain squared. This is your recipe here for subdivisions. Turn off that preview because it's going to get sloppy. And now, by default on my screen, I'm getting something that's broken down way too many times in the wrong direction and far few times in the other direction. So I'm going to use my panels to fix this. And I'm going to plug in a value of 1 in my V. Okay, that's the vertical direction. And the reason is that because I want a panel just to go across. So one panel going in this direction, but I need a number of subdivisions in that direction. Right, so I can increase the U value to have a little test here. I don't know, make it 50. It might be too many, but we'll see. Yeah, that's actually not a bad way to look at it. So now, you can see I'm starting to draw those, let's say, those window mullions across, or the panels that might start representing where those windows go. But each one of these bands is being divided 50 times, right? And if I take a look at this, maybe it's easier to see in the front view. These have a certain proportion based on the overall length of the surface and so on, but this one gets much smaller, and so you can see the proportions have changed pretty drastically. Not only is this the smaller band, but it's also the most extreme up at the top in terms of its length. And we end up with these kind of really long and very, very thin bands, which I don't think makes a lot of sense. Why subdivide a shorter surface the same number of times? If we want the windows to be the same size, we'd have to subdivide this a lesser number of times. Now, I'm not going to go through and try to make sure that they're all the same size, and I'm not going to make sure that they're all the same, that they're all planar right now. That's a totally separate process. Maybe not process, but a separate video that would make this one a little bit too long. But I will introduce a way of kind of at least using some of that data, the length of that curve, in order to affect how many subdivisions we actually get per surface, so to make it a little bit more parametric, a little less manual. All right. And to do that, I'm going to use a remapping process. So the first thing I want to do is get the lengths of all of these circles. Okay, so I'm going to grab my curve length component here, and I'm measuring them all out now. And if I hover over that, you can see the length is basically its circumference is anywhere from 151 to 158 and 112 and so on. Good. And the thing that I want to do now also is use this data to kind of massage those values into something that could be input into reasonable U values here. So I'm going to go to maths. I'm going to grab this remap component. All right. And I'm going to see what it needs. So what this is going to do is going to take any kind of set of values coming in within a certain domain and remap those values proportionally to a new domain, right? But it's not going to change. So again, it's not just going to change the numbers by division. It's going to literally remap them using the exact same numeric proportions, but with smaller values, right? So it's dealing with proportions and ratios as opposed to just straight up division. The first thing I need to do is figure out, first of all, what the domain of this is, but I can go ahead and plug those values in because that's the ones I'm changing. In my domain tab, I can grab the max and min component up at the top there, and that's going to give me my boundary, right? So my lowest to my highest. That's my source domain. Now the target domain is something we have to create. So we can go back over to the domain tab, we can construct a domain, and we can input custom values into A and B. All right, so we can just grab this panel, maybe copy and paste it over. I'm going to put my max value in at 50 and my minimum value in, say, at 30, okay, just to kind of test that out. Which basically means that the smaller the surface, the smallest surface will get 30 subdivisions, the largest surface will get 50, and everything in between will get those values. Now, these are floating point numbers, right? And we know we can't really use them. I mean, we can, it's just that Grasshopper is going to automatically kind of convert that by nature into an integer, so we can do that for it to actually just go to parameters, grab that little 7, which is actually an integer component. Oops. Yeah, here's our remap numbers. Up at the top is our R value, and our integers now have been kind of rounded to the closest integer. We need to graph this. Remember, we've got a graphed set of lists here. That's good, but this data doesn't match, so let's right-click, graphed, and then I can plug that in. And now what you'll see is a little bit more, I guess, a proportional, breakdown. These are more or less the same width, at least visually, as per this, the bottom curve, right? If you just look at where the panel intersects the bottom curve, you can kind of see that they're all around the same size. You can kind of play with this a bit. That, I think, is a little bit too much. It's just not. And so we're getting a little bit closer. Again, as a sketch, I think it's pretty good. If you had to start putting out some design diagrams, this would be a way to describe at least the intentions of the project before we get into the specifics of how to make it constructible and so on. And so here we are. So now we've got a series of surfaces that have been broken down into subs, and off we go. Now, what I like to do is join these. I'm going to do one more thing for you guys, which is to kind of unroll these into strips, to kind of talk a little bit about how a model like this could kind of also lead to an efficient fabrication process. So I'm going to join these, and I'm going to get rid of the, kind of turn off that preview. And there's my joined version. So now instead of separate lists of 47 separate panels, 50, whatever, now I just have basically 8 surfaces that I've joined together that are built of separate pieces, separate chunks. And here's where we'll need Lunchbox. It's got a handy little component that allows us to do an unroll. If you're using a Mac or if you don't have Lunchbox installed, that's fine. You can just kind of see what goes down here. It's really not involved. And just kind of watch along. And I'm going to go to Lunchbox, head into my, I think it's in Utilities, yeah, the Unroll BREP. I'm going to flatten well, I guess I don't have to. So I'm going to unroll these BREPs, and you can see what's going on by default here on screen. I'm drawing them at the origin, and they're kind of overlapping each other, and that's fine. We can move them across. But really what I'm seeing is the topmost all the way down to the bottommost strip that's being unrolled for us, as almost kind of like you would a sheet of paper or something, right? So if you were to create a paper model of this form, you would laser cut these pieces and bend them into position, right, connecting one side to the other along some kind of framework, and you would be able to at least get a kind of an approximation of the form pretty nicely. We could move them all apart from one another, and I'll do that last, which is to just kind of take our data that's coming out here. I guess I do need to flatten this, actually. If I look at my input data, I've got all those, or the unrolled here, it's kind of breaking them all apart again for some reason. I guess I can do two things. I can probably flatten this, and then yeah, so if I flatten twice, I'll get those surfaces to be kind of broken down into their as the joined again. The other way I could have done that is just rejoined again as the output. Who knows? Oh, it's because this was at false. I guess I could turn that to true, and then it doesn't matter if yeah. So if I turn this to true, these are then again separated, or kind of like broken into. But I'll flatten it because maybe the next step's a little bit easier, and that's just to kind of move them along just move them in the x direction a little bit apart from one another, so we can see them all independently. For that, I'll use a series, and start at 0. That's fine. Our n value is something we can set as an arbitrary value that will hopefully work, and we can always change it. And that's basically the distance between each one. The number of values in the series is going to be the number of items we have here, so we can measure that using the list length component over in the list tab. And now I have 8 values coming out. Okay, and I'm going to apply that to an x vector because that's going to be my move information. And I'm going to grab a move component. Okay, so I'm going to move all these things using that as my data. Turn that thing off. And it's moving them now maybe in the wrong direction because that's still just as or more confusing. So I'm just going to reverse this. And there we go. So now we get a better sense for how that breaks down. Okay, so bottommost, topmost. And the cool thing is, now that this is all live, if we go back, let's start goofing around a little bit. If we go back and we change some of these values, our strips will update, right? So our fabrication data will update accordingly. And you can see now that as the form changes, so too does its associated pieces. Okay. All right, so just a little bit about workflow at the end there. Again, parametric model for to kind of sketch out a form, a method statement, a geometry method statement, which we've created, which is basically the line work scaffold that creates the overall form, and all the parameters that are associated with that affect, the overall form within a certain range. And then talked a little bit about how that model could also be used to generate some fabrication information, right? To kind of break it down into a fabrication process, into flat panels, and even these kind of longer strips to kind of try to understand the form a little bit through that process as well. Okay. See you in the next one.